Hello and welcome to class. I want to discuss the concept of linear space. Linear space are defined over a mathematical term called field. You can define linear space explicitly without involving this mathematical term field. But then what is a field? A field is simply a set of numbers. Let me put it in writing. A field is a set of numbers. Let's call the set F, where the additive operation, the subtractive operation, the divisive operation, the multiplicative operation, and the divisive operation satisfy the following properties. For every x and y element of F. Now, for every x and y, for every two elements of F, you see that a set becomes a field if for every two elements of F, if plus is coming in between any two elements of F, the resultant effect becomes an element of F. Now, let's come to subtractive operation. Whenever for every two elements of F, if the subtractive operation comes in between two elements of F, it also produces, or the resultant is an element of F. Or the third one, if the multiplicative operation comes in between two elements of F, the result is also an element of F. And if the divisive operation comes in between two elements of F, the resultant, or the result of this operation, becomes an element of F. But note that y is not going to be 0 because division by 0 is not defined in mathematics. Okay, now using these four properties that these four operations satisfy, you will observe that there are certain properties that elements of F would satisfy using these properties. The first property is, let's come to addition. Now, you see the addition as an operation is an operation that doesn't depend on order. It doesn't depend on order. What do I mean? If x is added to y, it's the same thing whenever y is added to x. Hence, you see that elements of F are satisfying commutativity. So the elements in F satisfies what? Commutativity. We call this property commutative property. So we say that the elements in F satisfies commutativity. Hence, since plus itself is not dependent on order, for any three elements, the way they are grouped is still, if plus is interposed in the way they are grouped, it gives us same results. This is what I mean. For every x and y, if z is added, it's still the same result whenever you have this particular thing. So elements of F, which is set of numbers, satisfies associativity. We'll call this property associativity. Now, let's come to subtractive operation. You see that x and x is always a pair. Let's say this is a pair because this F belongs to F and this also belongs to F. This is a pair. Now, and don't forget, from the definition of a field, subtractive operation satisfies this, so that if F is a field, then whenever this particular operation comes in between two elements of F, which it produces an element of F. Now you have to understand that X subtracting X gives us 0, and this implies, using this property 2, this implies that 0 is an element of F. Now 0 is called, in mathematics, 0 is called, we call 0 the identity element with respect to additive operation. Now you see, since 0 belongs to F and X is also an element of F, now you see this is a pair. 0 belongs to, from here you see the 0 belongs to F and X is also an element of F. Now you see since subtractive operations satisfy this number 2 property, now 0 minus X will become an element of F because of this property 2. Now 0 minus X is minus X, so you see that minus X is an element of F. For every X that belongs to F, minus X belongs to F. Now in mathematics, minus X is called the inverse of X with respect to the additive operation. Let me put it in writing. Minus X is the inverse of X with respect to additive operation. Why is it called the inverse? Because minus X plus X produces 0, which is the identity element of F. Now, how many properties satisfy? We have commutativity, we have associativity, and we have that F contains the identity element with respect to additive operation, and we have that for each X that belongs to F, we have the inverse of X that belongs to F. Now let's check other properties it satisfies.